Welcome to another video. Today we will walk through the Hashmask analysis. According to their official website, Hashmask is a living digital art collectible created by over 70 artists globally. There are 16,384 unique digital portraits. In this analytics case study, we'll be using the data to gain broad understanding of what visual traits make a mask more or less rare. Let's get started. First, let's load the library. We will just be using tidyverse library. And the data we use is on this Google document. You can check it out. It contains the skin color, the character type, eye color, mask type, and item indicator, and a rarity score. So let's load the data and look at the first few rows. So we have these columns, but as you can see, the X2 and the URL, and the preview we don't really need, so we will just remove it. So I'll remove it, and now we have the ones that we want. We have the skin, character, eyes, mask, item, and rarity. Great. Each hash mask is unique, and here are traits that are provided. We have about 10 different skins, 7 different kinds of characters, 8 different kinds of eyes, 16 different kinds of masks, and about 5 different kinds of items. So there are a total of 1,545 unique combinations of these traits. So each of these hash masks has a rarity score that ranges between 0 and 100. These are based on the traits that we just discussed. For instance, only 1% of all hash masks have gold skins, and thus having gold skin will have a higher than average rarity score. Let's look at a summary of a rarity score. So let's do that. So we have hash mask. There are actually 2 null values, so let's get rid of that. And then we can just summarize. We can do mean. We can do median as well. Let's get a quick summary. So the mean score is actually about 23, and the median is 15. So in general, there are a lot of low rarity hash masks. Let's view the rarity score on a graph, see what it looks like. So we can do ggplot. So first, let's arrange the rarity score. And let's create a new column called index to keep track of the order. Then we can just plot them. So we can use the index as our x, y as our rarity. And let's do rarity to be our color as well. And then we have the geom line. And let's do a scale color. where if it's lower score, I'm just gonna give it a red color, and slowly, if it's higher, it will become green. Let's see what that looks like. So it looks like something like this. Okay. Let's make the line a little thicker so it's easier to see. Looks a little bit better now. So this is how the distribution kind of look like, right? We have a lot of them are below 50, and a small portion of it is above 50, and a really tiny portion is above about 90. Okay, so that's pretty cool. Now let's try to see distribution of the different traits. For instance, we can look at the distribution of the skin, for instance. So let's do that. So we can just plot them. So here I have a skin color vector. It just random colors that are assigned to each of these variable. These variables are exactly the types of skins that we have, and we will use these color to represent each of these. So let's get started. So I want to plot a bar chart. So we can do x is equal to the skin, and we're gonna color it with different colors. So geom bar, and then we can just do scale, fill, manual, and the values will be skin color. Let's see what that looks like. So looks pretty good. Well, we can do a little bit more, right? We can add a title, we can add more text to the y-axis, and lastly, we can also add a percentage on top of these bars, right? So let's add all of these to make it a nice graph. And also this legend is really redundant, right? Since we already know what bar represent which color, so we can remove that as well. So let's do that. First, let's add more text to the y-axis. So we can do scale y continuous bricks scales pretty bricks, and is equals to 20, for instance. And we can remove the legend, so we can do legend position being off. Let's add the percentage, so we have to use a job text, and we have to do label. We're gonna use the percent function from scales, and it's just dot dot count dot dot divided by the dot dot count dot dot, the sum. And then we have to identify the parameter is the count parameter for stat, and then we can adjust a little bit so that it get into the right position. So minus 0.25, and lastly we can add a nice title to it, like distribution of Hashmask skin types. So let's see. So now we remove the legend. We have a nice title now. We have all the percentage showing, and we have more ticks. Okay, so now it looks really good. Okay, right. We can also look at box plots uh, of these different traits, right? So let's see how we can do that. So let's see. So we can do ggplot, hashmask. Again, we're gonna look at the skin. We're gonna see how it different from the rarity perspective. And then again, we're gonna color it with different colors. We're just gonna use the geom box plot. And again, we will use the skin color vector that we created. And let's see what it looks like. Okay. So pretty good. So you can see that the wood has a lot of high rarity hash mass, and for gold as well. Right? There are a lot of high rarity hash mass for having skin equal to gold. Okay. Again, we don't need the legend. We can add more takes. We can add add a title, and so on. Right? So let's do that. So first, let's remove the legend. So it's the same as before. We can add more text to the Y. So breaks, scales, pretty breaks, n equals to 10. Add a title. Let's say just box plot of rarity versus skin. Cool. So there we have it, right? We have a very pretty box plot. Now it's your turn. Using the codes that we discussed, try to plot the distribution of Hashmask I types. Then also plot a box plot of rarity versus eyes. Okay, pause the video and come back when you're ready. So it's really similar to what we did. All we got to do is change a couple of things. Alright, first, of course, we need to create another vector for the eye colors. So you can just do that. You can pick your own color. And then this is basically the same code that we use. All we got to do is change X and fill into eyes instead of skin. And of course, change the title, right? So hopefully you figure that out. And we have this. So we have a lot of dark eyes hash mask. And really tiny portion is mystical. Okay. And for the box plots, again, it's similar. We just have to change a couple of things. Here, we just need to change X equals to eyes and fill equals to eyes, and the title eyes, and we will use the eyes color vector that we just created. So you get a similar graph that we see. So, for instance, glass eyes have a lot of high rarity score. Okay. Then after that, we try to fit a regression that gives rarity based on traits provided. This will give us an estimate of the effect of each of these individual traits on a Hashmask rarity score. So let's see how we can do that. Here we will use the relevel function to make the most common attributes as a base level. So it will be so everything that is comparing to it will be positive. So we can do linear regression, just LM. We're gonna do rarity compared to all the different traits that we have. So we're gonna use the relevel, and we just say factor. Gray is the most common one, so we're gonna put gray, and then we're gonna do relevel of eyes. Dark is the most common one. And relevel character. Factor character. The most common one is male. Then we relevel mask. The most common one is Mexican. And lastly, we have the item. The most common one is having no item. And the data set we have is Hashmask. Okay, let's look at the summary of the model. So we can see that some of the coefficients are not defined because of singularities. Right? This is because some of the traits are highly dependent on each other. Right? For instance, a hashmat has skin to be wood if and only if the character is puppet, and also if and only if the eyes are painted. So this unique combination will make this regression fail. So we can go around it by simply combining some of these traits into one column so that the uniqueness will disappear. So let's do that. So first we're gonna create a new column that combine all of these. So we're gonna use the function unite. It's just literally gonna concatenate them together. Then we're gonna create a new model that use these. So we have the relevel, CC. The most common one is gray, male, dark. And then we have the other two, the mask. Again, the most common one is Mexican. And the most common one is having no item. And the data is called data that we just created. So we run that. Let's take a look at the summary. So now we fix that issue. Right? Now we have a coefficient for all of these guys. Right? So for instance, right, if I look at golden toilet paper, so having golden toilet paper will have a huge increase on the rarity score. and having no item will have zero impact based on this um, regression that we created because we use it as a baseline. Alright, so for instance, here we have, if I have a gray, a male, and freak, then you will have a 19 increase on the rarity score and so on. And this is a really good regression, right? Since the rarity score does depend on the traits, right? So it's almost a perfect regression. Our journey into Hashmask shows us how to plot the rarity of a mask along a curve, how to use box plot to compare characteristic traits against their rarity score, and ultimately how to estimate the effect each trait has on masks exclusively. If there are any other interesting analysis that you can think of, feel free to share them with us. I hope you enjoyed the video. I'll see you next time.